Welcome students. I welcome you all back for our video lecture on industrial engineering and management. So this video will discuss about the remaining topics in unit 1. The previous video we have discussed about the functions of management, McGregor's theory, X, Y, organization structure, span of management, line and stop structure. And this video will discuss about the McKinsey 7S framework, boundaryless organization, virtual organization, and the last one important is the productivity measures. First, we'll discuss about what the 7S framework is about. It is, as the name indicates, it was developed by a person called McKinsey. So McKinsey 7S framework is purely based upon the different Yes which are involved in organization, and it gives you an idea about how effectiveness can be achieved in organization through interaction of these 7 key elements. There exists a domino effect when any one of the elements is transformed to restore the effective balance. So what basically a domino effect is? Effect which will happen on a positive note when you do something that you corresponds to do in the next one. Now say for example, whenever you are planning to reduce weight, probably you are getting into this mindset of developing your own kind of physical health. You get into two different kind. One thing is you start reducing your having a control over your food, and second thing is you will do a physical activity which are a part of the objective of reducing your weight. So domino effect refers to the effect which will happen in any one of the element is transferred, so to restore the effective balance. There are 7 A's involved. All the 7 A's are interrelated to each other, and the core principle of the McKinsey 7 A's framework is shared values, which will have an impact and which will have a direct relationship with all the remaining 6 A's. And those 6 A's are categorized into two different segments. One is the hard S element, the other is the soft S element. As you could see from the take my pointers. You could see the yes which are above the shared values is called as the hardest. The strategies, the structure, and the systems are called as the hardest. The other is which are this still, staff, and style. Why they are called as hardest elements is because they are easily identifiable and they are influenced by the leadership and the management. So they also called as to be tangible. Tangible is something which can be measurable. The other S elements called as the soft S elements are those which are culture driven, and they are basically depends upon or basically varies from one organization to the other organization. So hardest elements and softest elements are a key important aspect of your McKinsey 7S framework, and the hardest elements are easily identifiable and they can be tangible. A good example can be how your structure and what are the infrastructure which is available to a particular organization, which are easily identifiable and tangible, and this effectively influenced by the kind of leadership you have. So a McKinsey's framework suits to most of the organization, be it a product oriented or a service oriented organization. This 7S framework is applicable to any of the organization. Next, we'll now look up to the boundaryless organization. So what basically boundaryless organization is about? They are also called as an open organization. It completely eliminates the concept of having boundaries within the organization. The basic four boundaries which we see most of the organization are vertical boundaries, horizontal boundaries, external boundaries, and geographical boundaries. A boundaryless organization completely eliminates all those things, which means that they'll have a dual direction, which means that it is bidirectional. The information flow is bidirectional, the money flow is bidirectional, and the material flow is also bidirectional. So this includes what the major advantage of having a boundaryless organization is. It helps you to reduce the hierarchy and the functional separation, so which will provide an easier opportunity for the organization to have an integration among the different segments. A boundaryless organization, a good example can be your Toyota, because they across the boundaries, wherever you go, when the Toyota production system is followed, be it in India, be it in Japan, or be it in the United States, or wherever you go, you could see that it is irrespective of the boundaries, they follow the same procedure and the process. So it's easier for them to have an integrated kind of approach when delivering a product. So the key important aspect of boundaryless organization is the bidirectional flow, which will happen throughout the organization, be it in terms of material, be it in terms of information, or be it in terms of cash. The next set of organization is virtual organization, where there is a flexible business model where predominantly they use the concept of I 4.0 technologies, your IoT, your cloud, all those things comes under this. With the effective utilization of technologies, the employees are able to work remotely. The best example can be the COVID times, where most of the organizations were providing the opportunity for the employees to work from home. They are more flexible and more decentralized, and hence why the hierarchy is very less when compared to the other networks. A good example can be your Puma and Dell computers, where the employees are having given the opportunities of working completely from the work from home. So what is the core focus of this is the product development and marketing will be the core focus of virtual organization. The manufacturing sector, the research as well as the technological services, they will provide the support for the organization to run towards this product development. And the marketing firm and the testing labs will also have an relatively input. But obviously, with the availability of V labs and other more features, the companies are finding it much more easier to adapt to this virtual organization. Now we'll see about productivity, a key important measure of how do you work in an industrial engineering environment. So industrial engineering basically, as I said, it's a technical management subject. So when you look up to terms of productivity, any be it any product oriented or service oriented, whenever a person is employed as an industrial engineer, this ultimate aim is to increase the productivity without compromising the quality. That will be his ultimate aim. We basically measure productivity in terms of output by input. So output can be in terms of labors, in terms of capitals, or in terms of money. So input is the same thing applies, where we how much of materials are put in and how much of labor we are used in. So we have different segmentation of productivity. We'll see about that in the next slide. Measuring productivity. We measure productivity in terms of goods or service which is produced. We call them to be the output. In terms of manufacturing, we call them to be the goods, and in terms of service sectors, we call them to be the service which is provided. So how do you measure productivity? You measure productivity first initially through partial measures. With respect to each of these segments, the labor productivity will measure the machine productivity, the capital productivity, and the energy productivity. Once these are measured, you then measure the total productivity, which is a combination of all those things individually. So where does this miscellaneous fit in? Miscellaneous are the expenses, are the indirect expenses, the overhead expenses which are involved in making this product. So all these things will add up to your denominators, which is the input, and the output will be the goods or the services which are produced or which are delivered to the customers. Material productivity. As productivity, the basic measure is output by input. So in terms of material, it is how much of material is coming out of the industry and how much of material is dropped in. A good example is how you convert your metal ore into make a steel, and how do you convert the flours into make some good baked products, and how do you convert the steel into cars. All these things are your material input, the quantity of material which is fed into the production line, and how much of output is obtained. So how you can measure this productivity and how it can be improved? You can look up for any possible ways of reducing the waste and the scrap, and you can also look for cheaper materials, but at the same time it has to be ensured that the quality is not compromised. You can look up for any different ways of reducing the material consumption through a product design. The very best example is the introduction of additive manufacturing, where it's completely pure, eliminates the concept of reducing or eliminate the concept of wasting the products through manufacturing. And you can also have it a proper production planning and control can be driven. So all these things will help in ensuring that the material productivity is obtained by giving very lesser input and getting maximized output. The second category of productivity is labor productivity, where it's completely dependent upon how much of money is spent on the labor. So how you can improve it? You can provide training to the workers, and more specifically, you can have an allocation of work. As we indicated in span of control, allocation of works is key important, because the worker who is much more specialized in a particular work has to be given that particular work, and the other one, a person who is not much more specialized, maybe he can be clubbed together with a different team, and you can select his own kind of procedures in which will facilitate the easier transformation of the work into a finished product. So you can also look up to ways of improving the working conditions. Ergonomics comes into a key important aspect of this. We'll discuss about the ergonomics in the future chapters. The next measurement of productivity is capital productivity. Here you will deal only with terms of money. Predominantly, it's about making or buying a decision. Whenever an industry or an organization is looking to get a product or start manufacturing a product, first thing they look up to whether we have to make it on our own or we have to get from a third party. So when you get from a third party, you call them to be a buying of decision. When you make on your own, you call them to be about making decision. So how you can improve this productivity of capital? How you can improve this capital productivity is you can have a better utilization of the capital resource, land, building, and machines. Where you come your OE, the concept of OE, overall equipment effectiveness, comes into play. So how much of the effective utilization of machine comes into a greater picture, and you can also have an options of having a modern manufacturing techniques like FMS, which is flexible manufacturing techniques, which will help you to have a proper utilization of the available resources. The next productivity measurement is your machine productivity. It is about how much of utilization is done. What are the process or the methodologies in which you can study this? The first thing is your method study, which you will discuss or will see about in detail in your unit 2. There are various methods of measuring your productivity through this machine. There are process charts involved in it. There are Simo charts. There are memo charts. Many such options are available. So those things are will be the key important aspect of measuring your machine productivity. And you can also utilize, you can have this bring in this concept of I 4.0 technologies by utilization of IoT, cloud, and other more technological aspect. You can you can bring in this productivity to much more easier aspect. The last measurement productivity is your energy productivity. Is completely about how much of energy is carried over. As we have been knowing that every industry is striving forward towards achieving the sustainability goals, where the sustainability SDG goal number 14 says that you have to have a responsible consumption of the available resources. So you have to be proper about what is the energy which has been utilized or what is the energy which is spent for manufacturing the product. We'll see about a basic example of how measurement of productivity is done. A company is manufacturing 24,000 components and they are employing 100 workers, and the shift is basically an 8-hour shift. So they now wanted to employ some additional workers because they have got an order of delivering 6,000 additional components. They have got three options, whether they wanted to improve the number of workers to 30, 25 and 20. We need to calculate productivity based upon the number of labors here, because they have very specifically given about the workers condition. So when the condition is more specific about the machine, you go for calculating the machine productivity. Since the condition over here is more specifically about the workers, we'll go for labor productivity, where labor productivity, the total number of man hours divided by the total number of hours in which the man will be working. So the 24,000 components and will be for 24,000 components, you will be working about one component per man when the number of employees is closer to 100 workers, which is the current productivity measurement. So now the condition is they have got an additional order of 6,000. So now they have to look for options of improving. You have to ensure that the present productivity is not compromised by employing these three options. Even if you go for 30, 25 or 20, you need to ensure that the current productivity is either it should be closer to this or it should be exceeding this, but definitely not below this. So the first condition of employing 30 additional workers, the current production capacity 24,000. So the additional worker requirement, the additional component requirement is 6,000. So the total production requirement is 30,000. So once you have got this 30,000 of total production hours, then the current employment work is about the additional number of workers involved is 30. So it will be 100 plus 30, which is 130 workers. They'll be working for 8 hours of shift. So the productivity will be 0.96 component per man hour. Similar way, you can calculate for the productivity of 25 workers, which will be 1 component per man hour, and for 20 workers, it will be 1.04 component per man hour. So, what is the inferences you get over here? As an industry engineer, you have to make a proper decision making of, because you cannot deny this. This is bound to happen. You may get sometimes an additional order, or sometimes you may get a very lesser order. But as an industry engineer, you should find an optimal way of managing them. So, what is the number of workers you need to additionally employ here? The inferences here is the production has clearly increased 6,000 units, which you cannot deny upon. So it is closer to 25% of the actual production which has happened. So there is an increase of 25% to the actual production which has happened. So the labor productivity falls below the initial of loss one component per hour if more than 25 workers are hired. So which cannot happen. You have to ensure that, as you said, the current working condition is achieved. Even as an industry engineer, you have to ensure that whenever you are deploying additional resource, the current working condition has to be achieved, or you can exceed the current working condition, definitely not below this. So the final conclusion you will be coming here is not more than 25 workers should be hired for meeting this increased production. If that happens, then the productivity is going to be decreasing. It is going to cost the industry a huge amount. Now this is an assignment which I want you people to do it, and the corresponding questions will be posted here. You need to answer for the same. You have to have the productivity per machine hour. You have to compute the same, and you also have to draw your interpretations depending upon the case-to-case basis. So, as an industry engineer, what is the ideal condition? What is the differences you have made based upon this calculations you have done? Before we finish off this video, the last slide, I wanted to put up the factors which are basically affecting your productivity. There are so much factors involved. We have categorized them into controllable and non-controllable. as the name indicates, controllable or something which is within the control of the organization, that is called as the internal factors. And the non-controllable things are which is outside the organization limit, so you call them to be in external factors. So the external factors are further classified into structural, natural resource, and government policies, which you have to abide by. As I said, every organization is moving towards achieving sustainability, so which is a government policy, which you cannot deny upon. Then you have to look up to these factors which will create or which will impact your productivity. But on the other hand, there are certain internal factors. You categorize them as hard and soft factors. So this is where you can have a proper control over. You can have a control over the product, the people, the methodology in which you are performing, the technology which you are incorporating, and the style of management which are involved in. So when you control these factors, external and the internal factors, which obviously external factors are hard to control, but you should have the probability or should have the intentions of trying to reduce the intensity, because the problems will keep on coming. As we usually say that the human error is inevitable, so you should find some ways of trying to reduce the intensity of those errors. So external factors are hard to control, but you should find some ways of reducing their intensity. Whereas internal factors, you should have a proper control over all those factors, which will help the organization to increase their productivity by not deploying additional resources, by not deploying additional costs. They will be finding it much more easier, and this is what this process is about. So all these things are the overall picture about the factors affecting the productivity, and there are so much of concepts and the tools which are involved to control this process. We'll see about all those tools and concepts in the forthcoming units. And Unit 2 is more specifically focused towards the process, the time study method, the method studies, which are directly focused upon the improvement of productivity. So the remaining videos and the remaining contents of this particular subject of industrial engineering management will be more focused towards improvement of productivity through different measures. So we'll see about those tools and techniques in the forthcoming videos. Thank you.